Good morning, students. Welcome to class on Wednesday. Hope you've had a good couple of days off there. Of course, some of you might have been involved yesterday with the fine arts. I'm not sure. And actually, some of you today might have some fine arts competition also. But welcome back to class. Hope you've enjoyed your break from math. By now, Mr. Harmon should have passed back to you a stack of papers for each of you. Your quizzes will be in there. And all your homework that's been graded. Now, the quiz was already gone over in class last Friday. The only thing I will say is there were two of you who really struggled with the fill in the blanks, but you did pretty good on the math, and there were two of you that did pretty good on the math, but you really didn't do well at all on the fill in the blanks. So if you guys can kind of share with each other your secrets there about how you're studying, maybe you could balance each other out. But the only thing I would say about the quiz is this. Let me very quickly go over here and switch over to shape recognition. Okay, on the trapezoids, there's a little confusion on this one thing. There's a trapezoid, and then here's a trapezoid. There we go. Okay, now this one is an isosceles trapezoid because this side is congruent to this side. And of course, this side's parallel to this side's parallel to this side. Notice over here, this side is not congruent to this side, okay? But up here, this side is congruent to this side, okay? So this is an isosceles, and this is a regular trapezoid. Now, you need to get this, please. These non-parallel sides are called legs, okay? This and this are legs. This and this are legs. These angles here, this angle and this angle up here, are always, I don't care if it's an isosceles or a regular trapezoid, they are always going to be supplementary. That means they equal 180 degrees, always. So this angle here with one dot, this angle with two dots, if you were to add them together, you'll get 180. Same thing down here. This angle right here with one dot, this angle with two dots, they add up to 180. This angle here with a dot and this with two, they add up to 180. And why is that? Well, remember you learned when you have two parallel lines cut by a transversal, the consecutive interior angles, which would be angle 1 and angle 2. Those two angles are consecutive interior angles. You learned this last semester. Consecutive interior angles are always supplementary. And look, you've got a parallel line, cut by a transversal. And there's your consecutive interior angles right there. That's why they're going to be supplementary. That was one thing I thought a lot of you struggled with. But anyways, your quizzes are back to you. And let me go over some announcements. There will be a test on Friday. There will be a test on Friday. I'm going to give you the review sheet in a moment. You have no homework to turn in. The homework, there was no homework on Friday, so no homework to turn in. And there are some incompletes I want to announce very quickly. Let me go over those very quickly. So let me switch to a new page, and here we go. Ashley, you are still missing. Let me look at my list here. I am organized today, guys. I apologize. I just can't seem to find it here. Okay, here we go. Ashley, you are missing 5.3. And if I'm wrong, you email me or you call me and we'll get it worked out. Okay, you just have to show them to me. You're missing 5.3, 5. Now you turned a bunch of incompletes in. I'm proud of you, but you still owe me 5.3, 5.5, and 6.5. Now what are those assignments? Just look the video up. Remember, it's always Brian, Academy, Geometry, homework, and then 5-3 or 5-5 or 5 dash, it's actually a dash, 5-3 or 5-5 or 5-6, okay? And on there you'll see the homework assignment. Now this is kind of funny. I just said a second ago no one owed me anything. However, maybe you all were really scared on the quiz or really working hard, but no one turned in Thursday's homework on Friday. And so on Friday, you were supposed to turn in Thursday's homework, which was lesson 6.6. And if you'll go look on YouTube, of course, look at Brian, Academy, Geometry, homework 6-6. I would give you the assignment, I just don't have it in front of me. So no one turned that in. Hopefully you have it done. You forgot to turn it in. So I need that turned in today if you guys have it. Okay, well, here's your review sheet for the test. Now what we're going to do for the next couple days is we're just going to review. There's no need to start a chapter with just 2 days left. I'm going to try to be there Friday to give you the test. And so we're going to review for 2 solid days. If you want the 5 bonus points, then you will do this 40 problem review sheet. And if you do not, then that's up to you. But you'll have plenty of time in class to do this. So page 343, numbers 10 through 33, and page 346, numbers 1 through 17. And this video that I have listed here today is simply me working all these problems out. So go ahead and get your books out, get your notebooks out. Let's start reviewing for this test. This is going to be a great review for you, a big help to you. And actually, I also need to list on here the theorems and the definitions that you need to know also. So let me go ahead and draw a line here, and you'll want to write those down, so I'll list them out for you very quickly. But here's the review sheet. This is due by Friday if you want 5 bonus points, and let me list down here below now the theorems and definitions that you're responsible for. Alright, let's start off with your definitions. And I think I'm going to, well, I'll try not to erase these. I should have had this all typed up. You guys know I'm usually very prepared, and I apologize. I just forgot to have this typed. So here's your definitions. I'm going to write quickly. You need to know the definition of a polygon, definition of a diagonal. Again, pause this when you need to. Definition of a parallelogram, definition of a rhombus. It's going to be a tough test, guys. You're really going to have to study for this. Definition of a rectangle, definition of a square, definition of a trapezoid, and one more, and then pause the video if you need to, isosceles trapezoid. So I'm going to put ISOS period trap. Okay, there you go. So know those definitions. They will be fill in the blank. Fill in the blank. Okay, here's your theorems. Here's your theorems, T-H-E-O-R-E-M-S. Is that right? I'm drawing a blank. I don't think that's right. But anyways, I'm going to continue on. Theorem 6-1 all the way through. This is driving me nuts. There we go. 6-1, 2, 3, all the way to 6-5. Got it? So theorem 6-1 to 6-5. And then we pick up again with theorem 6-10 all the way to theorem 6-13. Okay? So theorem 6-1, 6-2, 6-3, 6-4, 6-5. And then theorem 6-10, 6-11, 6-12, 6-13. Corollaries. There are 3 corollaries you need to know. Corollaries. One is the rhombus corollary, one is the rectangle corollary, and one is the square corollary. Again, pause the video if you need to get caught up, or rewind it. And then lastly, I'm going to ask you to list out 5 ways to prove that a quad is a parallelogram. I'm running out of room, but I'll just say it again. I want you to know the 5 ways to prove that a quadrilateral is a parallelogram. Okay? I'm moving on like I always do. I'm going to start working these problems right now, starting with number 10. So please pause the video. Don't fight over the controls. Some of you have a question on number 10. Some have a question on number 15, whatever. Just share the video. Fast forward ahead to certain problems. Work together. Help each other. Work, work, work. Please, guys, work today in class. Work tonight, even though you have to go to church. Try to work tonight. Work tomorrow in class. Work Thursday night. And please be ready for your test on Friday. Okay, here we go. Problem number 10. And let me very quickly turn in my book to page 343. And let's start with number 10. Okay, is this a polygon? If so, tell what type it is. Okay, this is no. It is not a polygon because it has a curved area right there. So no. All right, number 11. Yeah, sure, definitely. It's a polygon. No problem with that. Let's see what kind it is. It has one side here, 1, 2, 3, 4, 5, 6. 6 sides. So what do we call a 6-sided polygon? That's right, we call it a hexagon. Hexagon. All right. Okay, continuing on, number 12. Most definitely, no problem with that. That's a polygon. Let's count the sides. 1, 2, 3, 4, 5, 6, 7, 8. And what do we call an 8-sided polygon? We call it an octagon. Octagon. Okay, number 13 says sketch the figures described. They want us to draw 2 different heptagons. Now, I've got to go back in my notes. I think a heptagon is a 7-sided figure. That sounds right. Heptagon. So, let's see here. Here's one. Just go 1, 2, 3, 4, 5, 6, 7. There we go. And then another one can just be, let's see, if it's 7, we would want probably 1, 2, let's see, 1, 2, 3, 4, 5, 6, 7. There we go. 2 totally different figures, and they're both heptagons. All right, let's move on to number 14. Number 14. They want us to sketch a quadrilateral with 1 right angle. Well, guys, that's pretty simple. There's our right angle right there. And now, as you draw the rest of your sides, make sure they don't form a right angle. So bring this one down there, and then bring this one up like that. There we go. Count the sides. We have 4 sides, quadrilateral, 1, 2, well, it looks like they're congruent. There we go. Here's one side, 2, 3, 4. There's my right angle. There's no way that's a right angle. There's no way that's a right angle. No way that's a right angle. So there's a quadrilateral that has 1 right angle. There we go. Moving on to number 15. Number 15 is a parallel. If you look at the direction, numbers 15, 16, and 17, it says they are parallelograms. So we know this is a parallelogram, and we're going to find, first of all, side BC. Well, guys, one of the characteristics of a parallelogram is opposite sides are congruent. So if DA is 4, then BC equals 4. There we go. And now they want us to find DC. Well, here's DC. And I know my numbers are blurry, but you've got your book to look at. DC, of course, is going to be congruent to this side right here. And as BA has a length of 8, so DC equals 8. All right, moving on. Okay, this is a parallelogram. They want us to find angle F. I'll put a little slash mark here. And they want us to find angle G. Now, here's what you should know about parallelograms. Remember, the directions tell you this is a parallelogram. So, in a parallelogram, that we know that opposite angles are congruent. Okay, so these 2 angles here are opposite and they're congruent. So, if this is 125 degrees, then the measure of angle G equals 125. Pretty simple. Now, the other thing you've learned is that consecutive angles in a parallelogram are supplementary. So, we're going to take 180 and we're going to subtract out 125, and that will leave us with 55. So this angle right here has to be 55 because 55 plus 125 is 180. So the measure of angle F equals 55 degrees. Moving on to number 17. Now remember, we do have a parallelogram. Okay, the directions say that. Now, in a parallelogram, the diagonals are not necessarily congruent, but what we know is this: they bisect each other. So PQ is congruent to QM, and LQ is congruent to QN. That's what we know. Now let's first of all find the length of, look at my pen here, PQ. Well, if from here to here is 8, then we know PQ also has to be 8. So PQ equals 8. Now the next thing we want us to find is PM. Well, students, come on, that's not too hard. I mean, if PQ's 8, if from here to here is 8, and from here to here is 8, then the whole thing has to be 16. So PM equals 16. All right, let's move on to number 18. Now, the directions for number 18, 19, and 20 say So we're 18 and 19, 20. We're going to tell whether or not we have a parallelogram. Now, students, please listen to me. Please don't look at the picture that you're given. You cannot go by the picture that you're given. So what we have to look at are different things that we've been taught about a parallelogram. Now, one thing about a parallelogram you've been taught is opposite angles have to be congruent. Well, look, that's blown right here. This is 125 degrees. This is 105. No. And on the test, I'll probably try to do this. I'll probably give you every picture looking like a parallelogram. But what I'll do is I'll put 130 degrees here, and down here I'll put 125. Don't go by what the picture looks like. Go by the facts you have in front of you, okay? So as soon as you see that we have angles here that are not congruent, no, not a parallelogram. A parallelogram has opposite sides congruent, opposite angles congruent. All right, now let's take a look at number 19. Well, one thing we learned, there were 5 ways that we learned to prove that a quadrilateral is a parallelogram. One of the ways is, and remember I told you earlier in class, I want you to know these 5 ways. Both sets or pairs, both sets of sides are congruent. That doesn't mean all 4 sides have to be congruent. In this case they are, and that's okay. What it means is this side here has to be congruent to this side here. And are they? Well, yes, they are. We have a congruency symbol here and a congruency symbol here. So far, so good. Now, is this side here congruent to its opposite side? Yes. Yes. We have a congruency symbol here and here. Now, folks, would you please listen to me? If you only knew that this side was congruent to this side and you didn't know these were here, you could not state that you had parallelograms, okay? You have to have both sets of opposite sides congruent, and we do. So yes, this is a parallelogram. Okay, moving on to number 20. Now, there's another way that there's 5 ways. Another way is if you have a quadrilateral in which the diagonals bisect each other. That was one of the 5 ways. I'm going to list the 5 ways real quick. Both sets of opposite sides are congruent. Both sets of opposite angles are congruent. Diagonals bisect each other. Both sets of opposite sides are parallel. And one angle is supplementary to both of its consecutive angles. Those are the 5 ways. Okay, well, the diagonals bisect. Look, here's a diagonal right here. Here's one right here. Y'all see that okay? Now watch this. This is 4, and this is 4. So I'm going to put a mark here and a mark here. This is 5, and this is 5. So 2 marks here and 2 marks here. The diagonals bisect each other. Yes, we have a parallelogram. Okay, moving on to 21. The directions for 21, 22, and 23 is solve for x and y. Solve for x and y. Now look, students, we have a square. They tell you that. And we all know the definition of a square is, of course, a parallelogram in which we have 4 right angles and all 4 sides are congruent. So if this is an 8, then we know this is an 8. What does x have to equal? Well, x has to equal 8, so there's one answer. And then this whole side right here has to equal 8. So y minus 5 has to equal 8. Let's add 5 to both sides, and y equals 13. Pretty simple. Okay, number 14 is a rectangle, and we're solving for x and y. Now remember, rectangles are parallelograms. Rectangles are parallelograms. And so we know 2 things here. Rectangles are a little special, okay? In rectangles, the diagonals bisect each other. That's true, okay? The diagonals bisect, but also in a rectangle, do you remember this? We learned this. The diagonals are congruent. We're going to use both of those truths. And now you're seeing how all of the things I've asked you to learn are going to start piling up on top of you if you don't learn them, okay? And we learned all of this during chapter 6. We learned that when you have a rectangle, you have a what? a parallelogram. And so if a rectangle is a parallelogram, which it is, then a rectangle has all the characteristics of a rectangle, but it also has all the characteristics of a parallelogram. So the diagonals bisect each other, and then if it's a rectangle, the diagonals are also congruent. So watch carefully, please. First of all, the diagonals bisect. That means this segment right here is congruent to this segment right here. Okay? You with me on that? So if this is 5, then x minus 1 also has to be 5. So x minus 1 has to be 5. Add 1 to both sides, and x equals 6. Now let's change color. Let's look at our y's. Now, remember, if these two diagonals are congruent, then that means this little length here is 5, and this little length here is 5. But hold it, that means this length here is also 5, and this length here is also 5. So all of these little segments are going to be 5. Okay, the diagonals are 10. The whole diagonal is 10. The whole diagonal is 10. So y plus 4 has to equal 5. So y plus 4 equals 5. Subtract 4 from both sides, and y equals 1. Again, guys, I move quickly because you can always rewind the video, so I'm moving on. Number 23. Now we have a rhombus. Now, don't forget, when you have a rhombus, you also have a parallelogram. Don't forget that, guys. So a rhombus has all the characteristics of a rhombus, but it also has all the characteristics of a parallelogram. Now, a rhombus has 4 congruent sides. All 4 sides are congruent. So if this is 10, then this is also 10. So now we know what y equals, don't we? That was easy. Y equals 10. This equals 10, and this equals 10. So x plus 4 equals 10. Subtract 4, x equals 6. Moving on to number 24. Tell whether the statement is true or false. All rhombuses, and I don't like that. It's really supposed to be rhombi. I'm old school, I guess. All rhombi are squares. No, that's not true. Here's a rhombus right here. Let me draw one for you, just for your pleasure and entertainment. Well, okay, sorry. There's a rhombus, length of, let's say we have a length of 5, a length of 5, a length of 5, and a length of 5. But is that a square? No, we don't have a right angle here, so no. All rhombuses are not squares. All squares are rhombuses, though, I'll tell you that. If I draw a square, that's a square, and it's also a rhombus. Okay, number 25. All rectangles are parallelograms? Well, yes. That's the definition, guys. The definition of a rectangle. You remember the definition? You better know it for your test on Friday. It's a parallelogram with 4 right angles. So yes, a rectangle is always a parallelogram. All rhombuses are rectangles. No, let's go back 2 pages. There's a rhombus right there. There's a rhombus. Is that a rectangle? No, not at all. So the answer to this is no. All right, moving on to 27. All squares are parallelograms. Well, yes. If you know your definitions, the exact definition that I gave you in this book gave you for a square is a parallelogram with 4 right angles and 4 congruent sides. That's the exact definition. Okay, moving on to number 28. These are all trapezoids. So 28, 29, and 30 are trapezoids. They are trapezoids. Okay, so let's take a look at this first one. Find the measure of angle P. Now, when class started, way back at the beginning, when you were still awake, remember? I told you, in a trapezoid, these are called legs, and the angles on the legs are always supplementary. Always. I don't care if it's a regular trapezoid or if it's an isosceles trapezoid. It doesn't matter. So they want you to find this angle right here, while this angle here and this angle here are on the leg. They have to be, sorry about that, they have to be supplementary. So I'm going to take 180, subtract out 111, and that'll give me 69 degrees. So the measure of angle P is 69 degrees. Okay, moving on to number 29. Find the measure of angle C. Now, would you please watch this and listen to me, guys? Do you see this congruency symbol here? Do you see this one? Do you see your parallel sides? CD and BA are your what? bases because they are your what? They are your parallel sides, okay? Look at your legs. Your legs are BC and AD. Do you see how they're marked congruent? Guys, they're marked congruent, and that means you have a special trapezoid. Remember, when the legs are congruent, you have an isosceles trapezoid. If you have an isosceles trapezoid, and only when you have an isosceles trapezoid, not a regular trapezoid, but when you have an isosceles trapezoid, the base angles are congruent. So that means this angle here is congruent to this angle. I'm going to put two slashes up here. This angle here is congruent to this angle here. So they're asking you to find the measure of angle C. Well, it's going to be 71 degrees. So the measure of angle C equals 71 degrees. I want to stress this again. The only time that base angles are congruent is when you have an isosceles trapezoid. All right, moving on to number 30. Now, look what we have. We have a beautiful trapezoid here. Look, there's your parallel sides. And remember this TU, what we call that? We call that, oh, we don't call it that. We call it a mid-segment. Remember, your quiz just had a bunch of these. And how do you find a mid-segment? You take the two. Now you're like, well, Mr. Earhart, we're used to this thing being like this. Let me show you here. We're used to seeing this thing turned around, so it looks like that. I know you are. I understand that. And I know it's a little confusing, but hey, you can have these parallel sides. I don't know what to do now to get this thing back. Woohoo. Maybe we'll try this. Here we go. You do not have to have the parallel sides running. They can run this way too. So we take our, this is a base and this is a base. Remember how to find the mid-segment? 13 plus 9 equals 22, and then divide it by 2. So 22 divided by 2 would give you 11. So the answer, or the length of TU, find TU, the length of TU is 11. All right, let's continue on to number 31. Number 31. On number 31, they want to know, is this a rhombus? Well, students, I'm going to tell you something right now. I can take this object right here and stretch it out and make it like this. And still have 73 degrees right here. And still have 73 here. And still have 107 here and 107 here. Okay, look, this could be a rhombus. It looks like it, but we don't know for sure unless we know that all four sides are congruent. And we don't know that. We do not know that. So you cannot state that this is a rhombus for sure. Might be, might not be. Here's a counter example here. I stretched it way out. I kept the angles the same. That is not a rhombus. It's just a trapezoid. Remember what I told you. Look, if this line here, now watch this, is parallel to this line, then these two angles here had better be supplementary. Well, let's see if they are. 84 plus 98 would be 182. Nope. So I know for sure that this line here is not parallel to this line here because these two angles are not supplementary. All right. Well, let's maybe the other. Remember, Mr. Earhart doesn't always draw pictures to look the way they should. So maybe this side is parallel to this side. Remember what a trapezoid has to have? It has to have one set. Don't forget that. A trapezoid has to have one set of parallel sides. So maybe this is the parallel. Maybe this side here is parallel to this side. Well, not sure why it's doing that. If that's the case, then this angle here has to be supplementary to this angle. If this line here is parallel to this line here, then these two angles have to be supplementary. Let's see if they are. 84 and 79. 163, not even close. No, this is not a trapezoid. Okay, number 33, is this a rectangle? Well, look, guys, this is a 9 and this is a 9, so the whole diagonal is 18. This is a 9 and this is a 9, so this whole diagonal is 18. Yep, When two diagonals of a quadrilateral are congruent, we have a rectangle. Yes, that's a rectangle. Okay, moving on to the next page, number 1 says sketch a hexagon, label its vertices. Okay, I can do that. 1, 2, 3, 4, 5, 6. There we go, close enough. And we'll just call it A, B, C, D, E, and F. There we go. Moving on to number 2. Number 2 and 3. State whether it's a polygon, and if it is, tell what kind. So kind of a little bit, repetition here. Yes, it's a polygon, and we have 1, 2, 3, 4, 5, 6, 7. 7 sides. So we are looking at a heptagon. Heptagon. All right. Number 3. No, it's not a polygon. It has a non-connected side here. All the sides have to connect at their endpoints. No, it is not a polygon. Number 4, find MD. Now, number 4, let's see. Okay, they want us to find this angle. Now, I was kind of stumped for about 2 seconds there. I was like, wait, is it a parallelogram? What is it? Well, first of all, let me get these numbers. This is 80 right here. If you'll look in your book, you'll see that. And this is 70 right here. Well, guys, I don't know if it's a parallelogram, what it is. But, parallelogram, rhombus, square, rectangle, trapezoid. But I know it's a quadrilateral. It's got 4 sides, 1, 2, 3, 4. And remember, a quadrilateral, the 4 angles always add up to what? 360, remember that? So I know one angle is 80, one angle is 70, and one angle is 90. So 90 plus 80 plus 70 is 240. So if they've all got to add up to 360, let's take 360 and subtract out 240, and I'm left with 120. So there you go. There's the measure of angle D, 120. Woohoo! Moving on, number 5. All right, number 5. It says in the directions we have a parallelogram. We're going to find the values of x and y. Now remember, if we have a parallelogram, opposite sides are congruent. So if this is 7, y is 7. That's pretty easy. Okay. Now, also, if you have a parallelogram, opposite angles are congruent. Opposite angles. So we know that 2x, I know this is a little blurry, but you can look in your books and see it. 2x has to equal 122. Divide both sides by 2, and x equals 61. Okay, moving on to number 6. Wow, that's really bad. This is a 70 right here, and this is an x, and this is a y plus 10. Y plus 10 in parentheses. Okay, now we do have a parallelogram. It states that in the in the directions. And look, right, this is kind of scary. Look, I mean, x, this angle here, equals this angle up here. So x equals y plus 10. That's got 2 unknowns. That's weird. How are we going to solve that? Well, let's look at the x. Yes, in a parallelogram, opposite angles like these two are congruent. But don't forget what else you've learned. Consecutive angles are supplementary. So if this is 70, then what does this have to be to give you 180? Well, real quick, we're going to take 180 and subtract 70 degrees, and we're left with 110. So x equals 110. There we go. So that helps a little bit. So x equals 110. So now where the x is right here, I can go ahead and put 110. So there we go. So now I really have 110 equals y plus 10. Let's subtract 10 from both sides, and 100 equals y. Let's go over that again quickly. I found x first because these two angles right here that my pen is on, these two angles right here have to be supplementary. All right. And then once I knew this is 110, then I knew y plus 10 had to equal 110. Subtract 10 from both sides, and y equals 100. All right, number 7. Let's see if we can't make this a little better. That's a 4. That's a 4. That's a 7, and that's a 7. The directions say, tell whether the quadrilateral is a parallelogram. Tell why or why not. Okay, well, let's see here. First of all, one of the ways to prove that a quadrilateral is a parallelogram is if both sets of opposite sides are congruent. Well, this is congruent, and these two sides are congruent. So yes, we have a parallelogram. That's one of the ways to prove that. All right, number 8. Ooh, be careful. Yes, these two angles are congruent, but are the opposite angles congruent? No, they're not. No, they are not. These two angles here are not congruent. No, you cannot state that's a parallelogram. No, absolutely not. The opposite angles, both sets of opposite angles have to be congruent. All right, number 9. Now watch this carefully. I'm going to kind of highlight it for you here. Maybe I can use my shape recognition and make it a little better. All right, and now we've got a couple diagonals. There's a line drawn here and a line drawn there. Not the best, but you can see it in your book. Now, in your book, there's 2 marks here, 2 marks here, 1 here, and 1 here. Guys, yes, it's a parallelogram. Look, what's one of the ways to prove that a quadrilateral is a parallelogram? The diagonals bisect each other. Here's a diagonal, right here. Here's a diagonal, and they bisect each other. This little piece here is congruent to this piece here, and this little piece here is congruent to this piece here. Yes, it's a parallelogram. All right, number 10. Yes, remember one of the ways I taught you to prove that a quadrilateral is a parallelogram was this. I said you take one angle right in the middle here, and if that one angle is supplementary to both of the angles on both sides of it, then it is a parallelogram. That's one of the 5 ways. How do we word that? We say if one angle in a quadrilateral, if one angle is supplementary to both of its consecutive angles, then it's a parallelogram. So 70 plus 110 equals 180, and then 70 plus the other angle, 110, equals 180. Yes, we have a parallelogram. Yes. All right, number 11. Let's see. What other formation do you need to conclude that the figure is a rectangle? Well, we know that this side is congruent to this side and this side is congruent to this side, so we know for sure that we have a what? A parallelogram. The only thing we're missing that we have to know is we have to know we have right angles. Okay, so it's asking what were you missing? What information were you missing to state this is a parallelogram? You were missing the fact that you need right angles. Okay, you have to have right angles to have a rectangle. All right, number 12. In rhombus JKLM, find the values of A and B. So we know we have a rhombus, and with a rhombus all 4 sides are congruent. So A equals 11 because this is 11, so A equals 11, and 3b minus 1 has to equal 11, so 3b minus 1 equals 11. Let's go ahead and add 1 to both sides. That would give us 3b equals 12. Now let's divide both sides by 3, and b equals 4. There we go. Moving on to number 13. Number 13. We have a trapezoid. It says find S and T. No, find S and Q. There is no T. All right. Well, I taught you guys at the very start of class today. I said, look, your parallel sides in the trapezoid are your bases. The other 2 sides in blue here are called your legs. That's a leg and that's a leg. And I told you guys the 2 angles on the legs are supplementary. So if this is 68, simply take 180, subtract 68, and you'll get 112. So S right here has to be 112. Now, look, here's another leg. This angle right here has to be supplementary to this angle. So I take the 180 and I subtract 122 and I get 58 degrees. So this angle right here is 58. There we go. Do you see how I did that? I'm going to circle these in red. These 2 angles had to add up to 180, and these 2 angles had to add up to 180. All right, moving on to number 14, an isosceles trapezoid. We're going to find, excuse me, I apologize, not an isosceles trapezoid. That's wrong. I'm sorry. Just a trapezoid. And they want us to find the mid-segment. Well, take your 2 take your 2 parallel sides, add them together, and divide by 2. 28 divided by 2 equals 14. All right, moving on to number 15. Determine whether the quadrilateral is a trapezoid, parallelogram, rectangle, rhombus, or square. I'm going to list everything. First of all, we know the opposite sides are congruent, both sets, and the opposite angles. So we know for sure we have a parallelogram. So that's a given. Okay, I'm going to abbreviate. All right, now we know that It's a parallelogram with 4 right angles, so we know it's a rectangle. And then we know it's a parallelogram that has 4 congruent sides and 4 right angles, so we know that it's a square. And we also have a parallelogram with 4 congruent sides, which is also a rhombus. So this would be all 4. All 4. All right, number 16. Now be careful here. Okay, we know we have parallel. I'm really getting irked at this thing. All right, we know that all right, let me throw it out the window here. Okay, we know that this side here is parallel to this side here. Okay, so remember, guys, that means that when two parallel lines are cut by a transversal, their consecutive interior angles are supplementary. So if this is 90 right here, then this also has to be 90 right here. All right. Now, this is going to be so hard to see, guys, and I know that, but look, we do not know that this side here is parallel to this side here. You don't know that. You cannot prove that, okay? Now, it looks like it, but you don't know that. The only thing you know for sure, students, is that you have one side here and this side here that are parallel. Now, what do we have when we have one set of sides parallel? We call that a trapezoid. Trapezoid, okay? All right, moving on to number 17. Did I skip 16? No, I did. Okay, number 17. All right, number 17. Are you given enough information in the diagram to conclude that EFG is a rectangle? Well, let's see, guys. First of all, I have a question for you. Is this side parallel to this side? Yes, it is. Is this side parallel to this side? Yes, it is. So we know we have a what? Parallelogram. Now remember, parallelogram there. Now remember, you need 2 things for a rectangle. You have to have a parallelogram. We have that. Check. And you have to have 4 right angles. When I hold it, hold everything. We only have one. Nuh-uh. We just said we have a parallelogram, right? And if we have a parallelogram, we know opposite angles are congruent. So if this is 90, what does this have to be over here? 90. We also know in a parallelogram that consecutive angles, angles that are side by side, are supplementary. So if this is 90, then what does this have to be right here? 90, because 90 plus 90 is 180. And if that's 90, then the opposite angle has to be congruent, which is 90. So yes, we do have a parallelogram. We do have 4 congruent, or we do have 4 right angles, excuse me. So yes, we do have a rectangle. I hope this has been a help. Play this thing as many times as you need to. Go over it, and please study your notes and be ready for your test.